Hello, I hope you're doing great. Uh, my name is Sebida Azizi. I'm a master's student in the Department of Urban and Regional Planning in University of Illinois Urbana-Champaign, USA. I'm very honored to be invited as a speaker for this third Global Summit on Advances in Earth Science and Climate Changes. I find it really helpful to share my recent paper and my recent findings with other researchers around the world. I feel that's a great chance for all those scholars and those people that are active in climate changes to share their experiences because we all know that climate changes is happening and it's real, so we need to be prepared. We need to share our knowledge in order to find the best ways to kind of stop climate changes somehow or stop the impacts of climate changes, our cities and the humanity. And yes, again, I'm very thankful for this chance to do this presentation. I'm going to share my recent paper with you, Urban Climate Dynamics, Analyzing the Impact of Green Cover and Air Pollution on Land Surface Temperature. We did a comparative study across Chicago, San Francisco, and Phoenix. If I want to give you a brief overview what we did and what is the importance of doing this research, I will start with the fact that rapid urbanization worldwide has significantly altered urban climate and creating a need to balance urban growth with thermal environmental quality for sustainable development. In our study, we examined the relationship between land surface temperature, or LST, and urban characteristic, particularly focusing on how green cover can mitigate urban heat and how air pollution can increase temperature. This study investigates the relationship between atmospheric pollutant like SO2, NO2, CO, and ozone, and the normalized difference vegetation index or NDVI with land surface temperature LSD using regression and correlation analysis. Regression analysis is employed to estimate the coefficients of independent variables and quantify the impact on LSD, and correlation analysis assesses the linear relationship between variables, which could provide insight into their pairwise association. The result reveals significant association between atmospheric pollutant like NDVI and land surface temperature, which contribute to our understanding of the environmental factors influencing LSD dynamics and kind of informing climate change mitigation strategies. The observed inconsistencies in correlation across cities highlight the importance of local context in environmental studies. Understanding these variation can help us in developing tailored urban planning policies that consider unique city characteristics for more effective climate resiliency. Oh, before that, before moving to the case studies, I want to give you some brief explanation of what is urban heat islands and what are those indexes we chose for this study. One of the most significant consequences of urban and or rapid urbanization is the urban heat islands, or UHI effect, where urban areas experiencing higher temperature than the rural counterparts. This phenomenon is primarily driven by the replacement of vegetation with impervious surface such as concrete and asphalt, which absorb and retain heat. These temperature variation within cities are influenced by the level and type of urbanization. UHIs exacerbate existing urban heat and posing health risk to the residents, particularly during the hot summers, and impacting both children and adults and diminishing the urban quality of life. Understanding the mitigating the UHI effect is crucial for enhancing thermal comfort and reducing energy consumption and improving public health in urban areas. And for the indicators we chose for this study, the first one is normalized difference vegetation index, which is a widely used indicator of green cover, which allow us to quantify the extent and health of vegetation in urban areas. Higher NDVI values correspond to cooler surface temperature, which could kind of highlight the importance of urban greening and greenery initiatives in UHI mitigation. One of the other um, I mean, the On the other hand, the atmospheric pollutants such as sulfur dioxide and nitrogen dioxide, monoxide, and ozone can exacerbate urban heat island. Uh, they contribute to greenhouse effects and they kind of alter the atmospheric chemistry. These pollutants absorb and re-radiate infrared radiation, which could result in increasing surface temperature, which also can impact the air quality. Now let's move to our case study of Chicago, Phoenix, and San Francisco. Uh, for this study, we selected these three major cities in US for several reasons. The first reason is because of their diverse uh, climatic condition, and the second reason is urbanization pattern, which could vary in these three cities. Also, the level of vegetation cover and air pollution kind of showed different pattern in these three cities. So I think it's important to do kind of doing such comparative studies to see that how kind of local context and the geographical location of the cities and the pattern of the urbanization and all those characteristics could impact the UHI effects. First, I'll start with San Francisco, which is the second most densely uh, populated city in US. The city geographic and climatic conditions are significantly influenced by its proximity to Pacific Ocean, which could result in cool, foggy summers and moderate temperature. San Francisco faces numerous challenges related to climate changes, which include the extreme heat, sea level rise, storm, floods, wildfire, and drought. I did have a chance to do a review of San Francisco Climate Action Plan, and it seems that the city is trying to target these issues in a practical way with some practical strategies. And I feel that studies like this would help those policymakers and those who are involved in creating the climate action plan to, plan better and in a different way for, mitigating the impacts of the urban heat island. The other important factor is about the vulnerable population in San Francisco, such as homeless people and elderly, which are particularly at risk of the, uh, you know, heat-related disease, especially during those extreme heat events. The city's homeless population increased by over 13% between 2017 and 2024, and 39% of the homeless population suffers from disabling medical conditions. The senior population aged over 65 comprise over 14% of the total population, and which could pose significant risk due to the aging infrastructure and limited access to air conditioning, which pose huge risk to these vulnerable population. The elder citizens and also homeless people and people with some sort of disability. Uh, in here, we do have a picture which kind of represents the distribution, the spatial distribution of these polluting gases and also NDVI and LFE throughout the whole San Francisco. I skipped the part regarding the technical aspects of this research, but for those who are interested, for creating these maps and kind of calculate, kind of, finding the pattern, spatial pattern of these uh, environmental indicators, you can use Google Earth Engine, which is a very good open source data. It could give us some good data information for all the parts in the world, not just USA. So I do recommend you, if you're interested in the environmental research, like something like this, you have to go and research and do, more investigate the Google Earth Engine. I used Sentinel-5 images for the air polluting gases and MODIS for the LSD and NDVI. There are plenty of satellites, imagery that you could use for such researches. And the other thing is I use the JavaScript coding for that, and I also have the codes. If someone wants to, needs these codes, I can share it with them. And for the other city, the Phoenix, Chicago in Illinois, um, Chicago is characterized by humid continental climate featuring cold winters and hot humid summers. This city has also a diverse population of almost 3 million people. The winters in Chicago are cold, and with the average average around 20 Fahrenheit in January, while summers are very warm and hot with average around 85 Fahrenheit in July. Precipitation is evenly distributed throughout the year, and it's almost 35 inches annually. Chicago's proximity to Lake Michigan influences its local climate and moderating the temperature and increasing humidity. The city remains one of the most segregated metropolitan area. In my current research, we are trying to find if there is any trend between the social segregation in major cities in the US and also urban heat islands. And for the Phoenix, Arizona, which is located in the desert area, which has a desert climatic characteristic, and it also has extreme hot summers and mild winters. The city has a population of nearly 1.6 million, and it's the fifth most populous city in the whole U.S. The Phoenix experienced some of the most intense urban heat islands in the U.S., which is even exacerbated because of the extensive urbanization. And the if I want to give you some more information about the Phoenix, um, I would say that the result in hate and kind of I would say that the urban heat island effects, as I told you, was exacerbated by the extensive and rapid growth in the city, and leading to temperature increase of approximately 0.9 Fahrenheit per decade, which could show the heightened energy use during the summer and summer months, which kind of increase residential water consumption as well, and the emergence of the heat island also presenting significant challenges for urban planning and public health in this city. So, as I told you, choosing these cities as our cases cities was because of these differences in the pattern, urban planning pattern, and the climate condition. I also again skipped the part about the correlation analysis, regression analysis. You can find all this information in the article, which I just want to mention the key findings. For example, for the San Francisco, it showed that NO2 had a very significant positive correlation with LSD. And for example, if I want to compare the San Francisco with Chicago, for instance, the NDVI has less cooling effect compared to Chicago. We did some pairwise analysis for those cities, and also positive correlation between air pollution in air polluting gases like NO2 and CO and LSD was kind of was found in the Chicago, and also NDVI showed a cooling effect by reducing the LSD as it was predicted. And for the Phoenix, we found a positive correlation between ozone and LSD, and also NDVI showed a stronger cooling effect compared to other two cities. And if we want to talk about the key findings for the policymakers, which is really, I think, important to talk about it, um, I would say that the first thing is systematic relationship between air pollution and land surface temperature. I mean, the positive slope observed between NO2, CO, and LSD across different cities suggests that air polluting exacerbate the urban heat island effect, and increased pollution level trap heat and lead to higher surface temperature, as we all know. For the policy implication, I would say that cities need to implement stronger polluting control measures, and especially targeting these two polluting gases, NO2 and CO, and also other polluting gases to mitigate the urban heat island. And also, it's kind of necessary kind of highlight the importance of vegetation in urban cooling. Higher NDVI values indicate more vegetation are associated with lower LSD, which could demonstrate the cooling effect of green spaces. Also, for the policy mitigation, it would give us this suggestion to prioritize increasing the green cover through park green roofs and urban fires to combat rising the temperature. For the geographic and climatic differences, I would say that the differences in the climate and geographical features for the cities like Chicago, San Francisco, and Phoenix uh, could show that it is important for us to tailor our planning policies to each city based on specific features they do have. For the urban infrastructure and land use impact, I would say that urban density and land use pattern are also playing crucial roles in this in their absorption and pollution level. And also the urban heat island is something that we are trying to find more information about it and doing some more research about that, developing the sustainable land use and trying to find out how the pattern of land use could have an impact on urban heat island is also important. All of the other things is the socioeconomic policies, like the cities with considering the social segregation and the social distribution of the vulnerable population throughout the city, and how it could be related to the urban heat islands, or how urban heat island could more could have more damages on these vulnerable population is also very important. Thank you so much for listening to my speech. I would be happy to help you if you and kind of tell you more about my research and other researches that I'm doing. If you have any questions, let me know. You can send me an email and I would be more than happy to help you.